We are now ready to solve the problem. Go down below using the jobs item, double click on the jobs and create jobs dialog will show up. Give it a name such as solution of the sample truss. Notice that job is attached to the model that you created. That was the default name. We used the model 1. We'll say continue at this point and simply accept the defaults in the edit job step. And now you need to open the jobs and the solution that you created. Right click on that and then click with the left mouse button on the submit. And if you, while during the solve, right click on that and do monitor, it should show you a screen showing possibility of any warnings or errors that may show up on during the solution. In this case there is none. You notice that in the dialog down below it shows that the solution has completed successfully. So therefore if you open this screen a little bit longer, you notice that your job has been completed, as you can see here. And I'm going to close that a little bit more and right click on that job, and then when you right click on it, look at the results and you notice a bunch of information appear with large fonts. For this case, the way you change these things would be to go to viewport and the viewport annotation options. Under viewport annotation option you can uncheck the title block for instance, and if you say apply, you notice what goes away. And I really don't need this particular item, which is the state block, and I'm gonna click on that one or uncheck it and say apply. Furthermore, you can change the font size of these things, and for that you go under the legends tab. You notice the set font icon appears here. You can change that for the legend, for state blocks, etc., etc. For now we'll simply say okay. The solution has been done, and we're going to note up here the solution has been set. The primary results that we'll be looking at for S, and the Mises is an unfortunate abbreviation of von Mises, equivalent stress. I'm simply going to switch from S to U. That would be the displacement. Once again, you notice the legends are quite large. I'm going to keep that way so you can see the results. The magnitude is that the magnitude of the displacement is displayed at the locations of interest. That magnitude is a square root of sum of the squares. You can go to U1 for instance. That would be the x direction displacement. And if you really want to look at the value of the displacement at the only node that you had, there's an icon down below here that is not showing up right now because my screen is a little bit on the small size. If you hover over it, you'll see it's a probe values icon. I'm going to click on that one. You'll notice that it is going to ask you what you want to probe. The probe is for elements. I'm going to switch that to nodes. And watch what happens if I move the mouse and I'm simply hovering over that node number, and you note the result. If you want to keep that result in the screen probe, if I move away from it, this number goes away. So I'm going to click on it once with the left mouse button. You notice the number will stick this time. That shows you that the node 1, the displacement along x direction is about 1.26 millimeters. And if you want to switch that to the displacement along 2 direction, go up here from U1 to switch to U2. It gives you a warning message that you're changing the result. We'll say yes, and once again you hover over that number, click on it once. You notice what the number is, about the negative 3.9 millimeters for the vertical displacements that match what we had done with hand calculations in the class. So I'm going to cancel out of this thing and switch to the stress value. Again, notice the stress is the equivalent von Mises stress that you may or may not be interested in. I'd rather look at the component stresses. So I'm going to go down here and click on S11, and S11 should show you the component stresses. If I go and probe the values again, and look at, instead of nodes and elements, and hover over, I'm going to bring it down a little bit so you can see the values. If I hover over the red elements, you notice that the element 1 has a stress value of 66.7 MPa, which kind of matches the value we did calculate in the class. I'm going to move that out of the way a little bit so you can see the blue element, and as I'm hovering over that one, you notice the stress value is negative or compressive, 55.6 MPa. All right, so these are the results, and that should conclude the video tutorial for the sample truss model.